Hello there, and welcome to The Sleepy Scientist. Tonight, we drift into one of the quietest and most mysterious ideas in all of modern science. We move beyond planets and stars, beyond even galaxies, and into the gentle fabric of space itself. Here, in the deep background of the universe, there is something subtle that seems to guide the cosmos onto the larger scales. It does not shine. It does not clump, it does not announce itself with noise or light, and yet it may be helping the universe expand more and more over time. This is the calm and distant realm of dark energy. Before we begin, allow your body to settle. Let your shoulders soften, your hands rest comfortably, and your breathing slow without effort. There is nothing you need to focus on and nothing you need to hold in your mind. Whatever belonged to the day can begin to fade, becoming quieter with each gentle breath you take. Dark energy is not something we can touch or see directly. It is known through its quiet influence, measured through the slow behavior of galaxies and the stretching of space across billions of years. It is one of the most peaceful mysteries we know, not because it is solved, but because it is steady. It does not rush, it simply seems to be there, gently shaping the universe in the background. As we continue, we'll explore the most relaxing facts about dark energy. We'll observe how scientists discovered the universe is expanding faster over time, how this invisible influence might behave, and how it fits into the calm structure of cosmic space. These facts are not meant to excite or overwhelm. They are meant to slow your thoughts, soften your attention, and guide you gently toward rest. If you enjoy these calm journeys through the gentle side of science, you're always welcome to subscribe and return whenever you need quiet curiosity or peaceful sleep. But for now, allow your awareness to drift outward into the vast expanding universe, where even mystery can feel steady and safe. Let's begin. Dark energy is a name we give to something we cannot see directly, but can sense through the slow behavior of the universe on its larger scales. What makes it feel so calm is that it does not move like a storm, and it does not arrive like an impact. Instead, it seems to exist everywhere, quietly, as a background influence that gently encourages space itself to expand. It is not a force you would feel in your body. It is something that reveals itself only across billions of light years, where the universe has enough room to show its slow, steady stretching. One of the most soothing truths about dark energy is that it does not pull things apart locally. Your body is held together by electromagnetic forces. The Earth is held together by gravity. The solar system stays stable because the sun's gravity shapes the orbits of planets. Even the Milky Way remains bound because its stars share a common gravitational home. Dark energy becomes noticeable only when you look far beyond those systems, into the wide spaces between galaxy clusters, where gravity grows weaker and the fabric of space has room to expand almost undisturbed. The discovery of dark energy came from a gentle kind of evidence, not from a single dramatic moment, but from careful measurements of very distant supernovae. Type Ia supernovae are special because they reach a fairly consistent brightness, allowing astronomers to use them as standard candles to estimate distance. When scientists observed these supernovae in galaxies far away, they found they appeared dimmer than expected, meaning they were farther than predicted in a universe slowing down. This quiet mismatch suggested that expansion was speeding up, as if something unseen was calmly encouraging space to stretch faster over time. Another peaceful aspect of dark energy is that it works through the expansion of space itself, not by pushing galaxies through space like wind pushing leaves. In modern cosmology, we often describe galaxies as mostly staying in place, while the space between them expands. It is like dots on a slowly inflating balloon. The dots do not need to move on the surface itself grows. This idea feels gentle because it turns cosmic motion into a soft stretching, a gradual widening that happens everywhere at once without needing any loud mechanism. Dark energy is often described as making up the majority of the universe's total energy content. with ordinary matter being only a small portion. This can sound surprising, but it can also feel calming because it suggests that the universe is mostly made of things that do not clump into hard objects. Most of the cosmos is not planets, mountains, or metal. It is wide space, faint radiation, invisible components, and quiet fields. The universe, in that sense, is mostly softness and openness, with dark energy as one of its most gentle ingredients. A very relaxing scientific concept is that dark energy might be constant, meaning it has the same density everywhere, even as space expands. This idea is often linked to the cosmological constant, a term first introduced by Albert Einstein in the context of general relativity. If dark energy is truly constant, then as the universe grows larger, the total amount of dark energy grows too, simply because there is more space containing it. It is a strange and quiet kind of abundance, where emptiness itself carries a steady background presence. Dark energy is measured not by touching it, but by watching how the universe has expanded over time. Scientists use many methods, including supernova distances, patterns in the distribution of galaxies, and the cosmic microwave background, which is the faint afterglow of the early universe. These tools allow cosmologists to reconstruct the universe's expansion history like a slow timeline. The calm beauty here is that the universe leaves gentle clues about its behaviour, and we learn about deep mysteries by listening carefully to light that has travelled for billions of years. The cosmic microwave background, often shortened to CMB, is especially soothing to think about because it is the oldest light we can see, released when the universe was very young and hot. Today it has cooled into microwave radiation that fills all of space evenly. Tiny variations in the CMB help scientists understand the universe's composition, including dark energy. In a quiet way, dark energy is connected to this ancient light, not because it appears inside it, but because the geometry and evolution of space shape how that background glow reaches us. Another calm detail is that dark energy became dominant relatively late in cosmic history. In the early universe, matter and radiation were more important in controlling expansion. Gravity from matter worked to slow the stretching of space. Over billions of years, as the universe expanded and matter became more diluted, the influence of dark energy began to stand out more clearly. This means the universe has had different eras, moving from a hotter, denser beginning to a cooler, more open present where dark energy quietly shapes the future. One of the most restful ways to imagine dark energy is as a silent presence that does not need to announce itself. It does not form clouds or stars. It does not have edges or a center. It is simply part of space, everywhere, steady and consistent, guiding the largest scale behavior of the cosmos with the gentlest touch. And even though it remains mysterious, its influence unfolds slowly enough that the universe has all the time it needs, expanding quietly, stretching calmly, and continuing onward in the background without ever needing urgency. Dark energy feels especially calm when you remember that it is not something that rushes through space, but something that seems woven into space itself. Instead of behaving like a moving object, it behaves more like a background property of the universe, influencing how distances change over time. This means dark energy does not arrive from somewhere else. It does not approach. It simply exists everywhere at once, quietly shaping the way the cosmos expands, like a gentle rule that space follows without needing attention. A soothing detail is that dark energy does not create bright light or dramatic signatures on its own. We do not see dark energy directly through telescopes. We infer it through slow, careful measurement of the universe's geometry and expansion history. This makes it feel like a quiet mystery rather than a loud discovery. The universe reveals dark energy not through sudden events, but through subtle patterns in distance, brightness, and the way galaxies spread apart over billions of years. The effect of dark energy becomes noticeable only across very large distances, especially between galaxy clusters. Inside a galaxy, gravity dominates and holds stars and gas together. Inside a cluster of galaxies, gravity still largely keeps things bound. But between clusters, where distances are enormous, gravity weakens and dark energy's gentle influence becomes more important. This is comforting because it means dark energy does not disrupt the familiar structures of the universe. It works mainly in the wide open spaces where calmness already feels natural. In cosmology, the expansion of the universe is described by a quantity called the scale factor, which tells us how the size of space changes with time. Dark energy affects how the scale factor evolves, encouraging expansion to accelerate. The soothing part is that acceleration here is not like a car speeding up. It is a slow mathematical curve that unfolds over billions of years. The universe is not racing. It is simply stretching in a gentle, persistent way, like a fabric slowly relaxing outward. One of the most peaceful scientific possibilities is that dark energy might be exactly constant in time, meaning its density stays the same even as the universe expands. This is the simplest explanation and matches what we call the cosmological constant. If this is true, then dark energy is not something that grows stronger in a dramatic way. It is steady, uniform, and quiet, acting like a smooth background pressure that becomes more noticeable, only because everything else becomes more diluted as space expands. Another idea scientists explore is that dark energy might change slowly over time, behaving like a dynamic field sometimes called quintessence. This would mean dark energy has a value that can evolve gently as the universe ages. Even this possibility remains calm in character because the changes, if they exist, would be incredibly slow. A field that shifts over cosmic time would not create sudden transitions. It would move like a slow tide across billions of years, almost imperceptible in any short span. Dark energy is often described using an equation of state parameter, usually written as W, which relates its pressure to its energy density. For a cosmological constant, W equals -1. That negative pressure is one of the strangest and calmest ideas in physics because it suggests a kind of gentle outward push woven into space. It is not pressure in the sense of pushing on a wall, it is pressure as a property of the vacuum itself, influencing how space expands on the larger scale. The universe's expansion can be measured through something called the Hubble-Lemaitre law, which describes how galaxies farther away appear to recede faster. This recession is not galaxies moving through space like rockets, it is space itself expanding. Dark energy influences this expansion rate over time. When you imagine galaxies drifting apart in a quiet, widening universe, it can feel soothing because the motion is not noisy. It is silent stretching with distances increasing gently, like a slow unfolding of cosmic space. Large surveys of galaxies help scientists map how matter is distributed across the universe, revealing patterns called baryon acoustic oscillations. These patterns are like faint ripples from the early universe, frozen into the way galaxies are spaced today. By measuring the size of these ripples at different distances, scientists can track how expansion has changed, and therefore how dark energy has influenced the universe. This is calming because it means dark energy is studied through ancient patterns, like listening to echoes that have been travelling quietly through time. Perhaps the most restful thought is that dark energy sets a gentle long-term direction for the universe's future. If it remains constant, the universe will continue expanding and accelerating in a smooth, steady way. Galaxies beyond our local gravitational neighbourhood will drift farther away over billions of years, becoming dimmer and more distant. There is no sudden ending in this picture, only a slow widening into openness, where space becomes even quieter, and the universe continues its calm expansion without ever needing to hurry. Dark energy becomes especially soothing when you think about how quietly it reveals itself. We do not detect dark energy as a particle flying past a sensor, or as a wave striking an instrument. Instead, it appears in the slow story of distance and time, in the way the universe has expanded over billions of years. It is known by gentle evidence, by careful measurements that show space is stretching faster now than it once did, as if the universe is gradually relaxing outward more freely as it ages. One of the calmest perspectives is that dark energy does not compete with gravity on small scales. Inside galaxies, gravity shapes star orbits. Inside solar systems, gravity keeps planets moving in steady paths. Inside you, electromagnetic forces keep atoms bound together, making solid matter stable. Dark energy does not pull these structures apart. Its influence is so weak locally that it becomes noticeable only where distances are immense and matter is sparse. This means dark energy belongs to the widest, quietest parts of space, where openness already feels natural. The acceleration of the universe's expansion is sometimes described as the universe speeding up. But the calm truth is that the effect is subtle and gradual. When scientists say expansion is accelerating, they mean that the rate at which distances grow is increasing over cosmic time. This change is not something that happens quickly or dramatically. It is a slow curve over billions of years, so gentle that it would not be felt within any human lifetime. The universe is not rushing. It is simply continuing to expand with steady persistence. A soothing scientific idea is that dark energy might be connected to vacuum energy, meaning the energy of empty space itself. In quantum physics, even a vacuum is not truly empty. Fields exist everywhere, and they can have small fluctuations even in their lowest energy state. If vacuum energy contributes to cosmic expansion, then dark energy is not a substance sitting in space, but a property of space itself, like a quiet background hum present even when nothing else exists. In the framework of general relativity, energy and pressure both contribute to how space-time curves and evolves. Dark energy is unusual because it seems to have negative pressure. Negative pressure in cosmology does not mean suction in the everyday sense. It means that as space expands, the energy density associated with dark energy remains steady or changes slowly in a way that encourages further expansion. The calming part is that this behavior is smooth and uniform, like a gentle outward tendency embedded in the universe's fabric. Astronomers study dark energy using standard candles such as Type Ia supernovae and standard rulers such as baryon acoustics oscillations. Both methods involve using known patterns to measure cosmic distances. This is peaceful because it means the universe contains stable reference points, quiet markers that let us map its growth. Even in a vast, expanding cosmos, there are steady patterns that can be traced with patience. Dark energy also affects the geometry of the universe on the largest scale. By measuring the cosmic microwave background and the distribution of galaxies, scientists can determine whether the universe is flat, positively curved, or negatively curved overall. Current evidence suggests the universe is very close to flat on large scales, and dark energy plays a role in this cosmic balance. This is calming because it paints a picture of the universe as a smooth, even space, expanding gently without dramatic curvature that would distort everything. As the universe expands, light from distant galaxies is stretched into longer wavelengths, a process known as redshift. Redshift is one of the most soothing observational tools because it is simply a gentle stretching of light. Photons travel across expanding space, and as space stretches, their wavelengths stretch too, shifting toward the red end of the spectrum. Dark energy influences how quickly the universe expands, and therefore how the redshift distance relationship changes over time. It is a quiet link between invisible cosmic energy and softly stretched starlight. A calm truth about dark energy is that it becomes more important as the universe gets older, because matter becomes diluted. Matter density decreases as space expands because the same amount of matter occupies a larger volume. If dark energy remains constant, it does not dilute in the same way, so eventually it dominates cosmic expansion. This is not a sudden takeover. It is a gradual shift in balance, like one background influence slowly becoming more noticeable as others fade. Perhaps the most restful way to view dark energy is as a long-term gentle guide of cosmic evolution. It does not form sharp structures or violent events. It simply affects how space behaves over time. If dark energy continues as it appears now, the universe will keep expanding, and distant galaxies will drift farther apart, leaving larger and larger stretches of empty space between them. It is a future of widening quiet, where the cosmos grows more spacious, more open, and more still, continuing its slow expansion without ever needing urgency. Dark energy can feel calming when you think of it as one of the universe's most subtle background ingredients, working so quietly that it took almost a century of careful cosmology to even suspect it might exist. It does not glow, it does not form clouds, and it does not gather into objects the way matter does. Its presence is inferred from the way space itself behaves over time, as if the universe has a gentle tendency to stretch outward, slowly and steadily, like fabric relaxing across an enormous frame. One soothing detail is that dark energy becomes meaningful only when you zoom out far beyond anything familiar. Within a solar system, gravity is so strong compared to the effect of dark energy that planetary orbits remain stable. Within a galaxy, stars continue circling their center, held by gravity and the galaxy's mass. Dark energy does not pull a star away from its orbit or loosen the bonds of a planet. It becomes noticeable only where the universe is incredibly sparse and open, in the wide distances between galaxy clusters, where gravity's hold is weaker and space has room to expand more freely. The way scientists describe dark energy often involves a simple idea called the cosmological constant, which is the calmest possible explanation because it assumes dark energy stays the same everywhere and at all times. In that picture, dark energy is uniform, smooth, and steady. It does not ripple or clump. It does not change rapidly. It simply exists as a constant background density. This makes it feel like a quiet foundation of the cosmos, not a moving force but a stable property of the universe's structure. There are other possibilities too, such as dynamic dark energy, where the energy might change slowly over time. This could be described by a field that evolves gradually, sometimes called quintessence. Even though it sounds complicated, the calm reality is that if dark energy is dynamic, its changes would still happen over billions of years. The universe does not shift quickly on these scales. Everything unfolds slowly, and any variation in dark energy would likely be gentle and smooth, like a slow drift rather than a sudden turn. Dark energy is sometimes discussed through the concept of negative pressure, which is one of the most unusual and quiet ideas in cosmology. In general relativity, pressure contributes to gravity and the evolution of space-time. For dark energy, the pressure appears to be negative, meaning it creates a repulsive effect on the expansion of space. But this repulsion is not like a push you would feel. It is an effect that becomes visible only when you measure how the universe's expansion changes over time, a soft cosmic behavior revealed through distant light. The expansion of the universe can be mapped through careful observations of supernovae, galaxy clustering, and the cosmic microwave background. Each of these measurements acts like a quiet ruler or candle placed at different points in cosmic history. By comparing them, scientists build a gentle timeline of expansion. Dark energy enters that timeline as the reason the curve bends toward acceleration, as though the universe has slowly shifted from a matter-dominated era into an era where empty space has become more influential than the galaxies scattered within it. A peaceful aspect of dark energy is that it shapes the far future of the universe in a gradual way. If dark energy remains constant, expansion will continue accelerating and distant galaxies will move farther beyond our view as their light becomes more redshifted and faint. This is not a sudden disappearance. It happens slowly, over time, scales far beyond human history. The universe becomes quieter and more isolated in the far future, not through abrupt endings, but through gentle widening that increases the space between everything. The cosmic microwave background offers another calm connection to dark energy. that ancient light has travelled for nearly the entire age of the universe, reaching us as a faint glow from every direction. Dark energy influences the large-scale geometry through which that light travels. Small patterns in the microwave background, combined with other measurements, help scientists determine how much dark energy exists and how it affects expansion. It is comforting to know that the universe's earliest light still carries information that helps us understand its present behaviour. Another soothing idea is that dark energy might be part of the universe's tendency towards smoothness on the larger scales. Matter forms structures like galaxies and clusters, creating texture in the cosmic landscape. But dark energy appears to remain smooth, acting almost like an even background that grows more important as matter spreads out. This creates a cosmic balance between structure and openness, between clumping and stretching, between gravity's gathering and expansion's widening. Perhaps the most restful way to hold dark energy in your mind is to see it as the universe's quiet long-term motion. It does not demand attention through brightness or noise. It reveals itself only through patience, through distant observations, through the slow drift of galaxies apart. And even though we do not fully understand what it is, its influence feels gentle, consistent, and stable, guiding the cosmos into an ever more spacious future where the universe continues expanding softly with calm persistence across the deepest stretches of time. Dark energy can feel especially calming when you realize that it is not something happening in a distant corner of space, but something that may be present everywhere, even in the emptiness between stars. It does not appear as a glowing object or a moving cloud. It is more like a quiet background condition that affects the universe as a whole. If dark energy is part of space itself, then it is not hiding behind anything. It is simply too subtle to notice unless you measure the universe on the largest possible scales. A soothing detail is that dark energy does not compete with the forces that shape your everyday world. The electromagnetic force holds atoms together and gives matter its solidity. Gravity keeps you connected to Earth and keeps planets in orbit. Dark energy is far too weak to disturb any of this. Its influence becomes important only in the largest, emptiest regions of the universe, where gravity is spread thin. This means dark energy belongs to deep space, to the wide calm between galaxy clusters, where the universe is already quiet and open. The idea of the universe accelerating can sound intense, but the reality is gentle. Cosmic acceleration is a gradual change in the expansion rate over billions of years. It is not an explosion or sudden surge. It is a slow curve in the universe's history, like a very gentle change in how quickly distances grow. On human timescales, the effect is so small it feels like stillness. The universe expands quietly without sound, and dark energy guides this expansion in a way that is steady rather than dramatic. Astronomers describe the universe's expansion using the Hubble parameter, which tells how fast distances grow at different times. Dark energy affects how this parameter changes. When the universe was young and matter was denser, gravity slowed expansion. As the universe expanded and matter became more diluted, dark energy became relatively more important. This shift is calming because it is not abrupt. It is a slow transition, like one influence fading while another quietly becomes more noticeable in the background. Dark energy is often represented in cosmology as a smooth component with almost no clumping. Matter gathers into galaxies, stars, and planets, creating structure. Dark energy appears to remain evenly distributed, acting like a uniform background. This smoothness makes it feel peaceful, like an even ocean beneath the islands of galaxies. While matter forms the visible landmarks of the universe, dark energy may be the quiet foundation that shapes the overall stretching of space. One gentle scientific idea is that dark energy might be the cosmological constant, a fixed property of space-time. In that picture, dark energy does not change with time. It remains constant everywhere, which means it does not create complicated patterns or sudden shifts. It simply stays present, steady and uniform, encouraging the universe to expand in a calm, predictable way. The simplicity of this idea is soothing because it suggests the universe's most mysterious ingredient might also be its smoothest. Scientists also explore whether dark energy could be dynamic, meaning it changes slowly over time. If so, it might behave like a field that evolves, similar in spirit to how other fields exist in physics. Even in this scenario, the changes would be extremely slow. A dynamic dark energy would still unfold over billions of years, making it gentle in its behavior. It would be like a slow tide in the deepest ocean of space, rising or shifting so gradually that it feels almost constant. Dark energy shapes the far future of the universe in a calm way. If it remains constant, the universe will continue expanding and accelerating. Galaxies outside our local group will drift farther away over billions of years, and their light will become more redshifted, stretching into longer wavelengths until it becomes faint. This future is quiet and gradual. It does not arrive suddenly. It is like a slow widening of distance that makes the universe more spacious and still. The cosmic microwave background is another restful connection to dark energy. This ancient light has travelled since the early universe, filling space with a soft glow in microwave wavelengths. Dark energy influences the geometry of space through which that light travels and affects how structures grow over time. By studying the patterns in this background light and comparing them with galaxy surveys, scientists can estimate the amount of dark energy in the universe. It is comforting to know that even the oldest light in existence helps us understand the universe's calm expansion today. Perhaps the most soothing truth about dark energy is that it remains a mystery, but not an urgent one. The universe does not demand that we solve it quickly. Dark energy has been shaping cosmic expansion for billions of years, and it will continue to do so regardless of how fast human understanding grows. It is a quiet question that invites patience, curiosity, and calm reflection, reminding us that the universe can be vast and gently expanding, carrying its secrets softly in the background, while everything else continues its slow and steady motion through time. Dark energy feels calming because it is one of the universe's quietest influences, known not through direct contact, but through the slow behavior of space itself. It does not arrive as a flash or a sound. It is inferred from how the universe expands, from how distant galaxies appear farther away than expected, and from how that expansion changes gently over cosmic time. Dark energy is like a soft, invisible presence that shows itself only in the widest stretches of reality, where there is enough distance for its subtle effects to become visible. A soothing truth is that dark energy does not disturb the stable structures around you. Your body remains intact because electromagnetic forces bind atoms together. Earth remains whole because gravity holds it tightly. The solar system continues its steady motion, and galaxies remain bound by their own gravity. Dark energy becomes noticeable only in regions where gravity is weak compared to the size of space, such as the distances between galaxy clusters. It belongs to the great openness of the universe, and its influence is expressed as gentle stretching rather than disruption. The universe's acceleration was discovered through careful observations of Type Ia supernovae, which act as distance markers because they reach a predictable brightness. When astronomers compared these supernovae across different distances, they found that very distant ones were dimmer than expected, meaning they were farther away than predicted by a universe slowing down. This quiet mismatch revealed something profound. Expansion was speeding up. The discovery was not a single loud signal. It was a calm statistical pattern emerging from patient measurements across the sky. Dark energy is often described as having negative pressure, which sounds unusual but can be understood gently in the language of general relativity. In Einstein's theory, pressure contributes to the behavior of space-time. A negative pressure associated with dark energy would encourage space to expand faster. This is not like a physical push you can feel. It is a property of space that becomes apparent only when you look at the universe as a whole. making it feel like a soft background tendency rather than an active force. A peaceful concept in cosmology is the idea that dark energy may simply be the energy of empty space, sometimes called vacuum energy. In quantum physics, the vacuum is not truly empty. Fields exist everywhere, and even their lowest energy states can have fluctuations. If the vacuum has a small constant energy density, it would act like dark energy in driving cosmic acceleration. This makes the universe feel calm because it suggests that emptiness itself has a gentle presence, steady and uniform. Dark energy is measured through multiple independent observations, which creates a calm sense of confidence. Scientists compare supernova distances with measurements of galaxy clustering, baryon acoustic oscillations, and the cosmic microwave background. Each method offers a different view of expansion history, like different gentle instruments listening to the same cosmic rhythm. When these methods align, they form a consistent picture of a universe dominated by dark energy, expanding in a smooth and steady way. Baryon acoustic oscillations are especially soothing because they're ancient ripples, frozen into the distribution of galaxies. In the early universe, sound waves moved through hot plasma, creating patterns of slightly higher density. When the universe cooled, those patterns became imprinted in matter. Today we can measure them as a preferred separation scale between galaxies. By using that scale as a cosmic ruler, scientists track how expansion has changed, and therefore how dark energy has influenced the universe's growth over time. Dark energy also influences how structures form. In the early universe, gravity caused matter to clump, forming galaxies and clusters. As dark energy became more dominant, it began to slow the growth of large-scale structure because accelerating expansion makes it harder for gravity to pull matter together across vast distances. This is calming because it suggests dark energy does not create chaos. Instead, it gradually quiets the universe's ability to form new, massive structures, leading to a future that is more open, more spacious, and less crowded. The long-term future shaped by dark energy is often described as a universe that continues expanding forever, with distant galaxies becoming more and more separated. Their light will stretch to longer wavelengths, becoming faint and eventually disappearing from view. This is not an ending with sudden collapse. It is a gentle fading into distance, a slow drift that unfolds over trillions of years. The universe becomes quieter, with more dark space between islands of matter, as expansion continues its calm progression. Perhaps the most restful truth is that dark energy invites patience. It is a mystery that does not demand urgency. It has been shaping the cosmos for billions of years, and it will continue shaping it long after human time is gone. Whether it is vacuum energy, a new field, or something not yet imagined, its influence remains steady and smooth, like a quiet current in the deepest ocean of space, guiding the universe outward as it expands gently into ever greater openness. Dark energy can feel deeply calming because it is not an event but a background condition, something the universe seems to carry quietly within its structure. It does not flare, collide, or erupt. It does not produce sound or sudden change. Instead, it reveals itself only when you step back far enough to see the universe as a whole, where the slow stretching of space becomes visible through the drifting separations of galaxies over billions of years. Dark energy is like a silent rule of expansion, always present, always steady, never needing to announce itself. A soothing truth is that dark energy does not pull matter apart inside bound systems. Gravity keeps the solar system stable. Gravity and dark matter keep galaxies bound together. Electromagnetic forces hold atoms and molecules together with overwhelming strength. Dark energy is too weak on those scales to do anything noticeable. It becomes important only across vast distances where matter is sparse and gravity is diluted. This means dark energy belongs to the most spacious parts of reality, the places where stillness already exists naturally. The idea that the universe's expansion is accelerating can sound dramatic, but the acceleration is incredibly gentle. On a human timescale, the effect is essentially invisible. The universe expands at a rate measured in tiny fractions over enormous time. Even the speed at which distant galaxies recede is not a true motion through space like wind-blown objects. It is the result of space itself expanding. This quiet stretching makes the cosmos feel like a slow breath, widening softly over time rather than rushing outward. In cosmology, dark energy is often treated as a smooth component that fills the universe uniformly. While matter forms clumps, structures and shapes, dark energy appears to remain evenly distributed, like a constant background. This smoothness is calming because it suggests dark energy does not create lumps or turbulence. It does not gather into dense clouds. It stays quiet and spread out, acting like a gentle pressure that becomes noticeable only because it influences the large-scale behavior of space itself. One of the simplest explanations for dark energy is the cosmological constant, which represents a constant energy density in empty space. This idea is soothing because it is stable. If dark energy is constant, it means the universe has a steady background ingredient that does not change abruptly. It exists everywhere equally. It does not come and go. It does not depend on location. It simply remains present as the universe expands, guiding cosmic acceleration in a calm and consistent way. Scientists study dark energy by building a history of cosmic expansion. They look at light from supernovae, patterns in galaxy distribution, and the faint cosmic microwave background. Each measurement acts like a calm marker of time, allowing researchers to map how quickly the universe was expanding at different ages. Dark energy appears in this history as the point where expansion stops slowing and begins to accelerate again. This transition is not sudden like a switch. It is a gentle shift over billions of years, like a slow change in the slope of a long, smooth curve. A soothing feature of dark energy is that it influences the universe's future without creating immediate disturbance. If dark energy remains constant, the universe will continue expanding forever, and that expansion will gradually accelerate. Distant galaxies will drift farther away, and their light will become more stretched, fading into longer wavelengths. This is a quiet future where the universe becomes more open and more spacious, not through destruction but through gentle separation. Dark energy also affects how structures grow. In the early universe, matter clumped under gravity to form galaxies and clusters. As dark energy became dominant, it began to slow this growth on the largest scales. Gravity still forms structures locally, but across cosmic distances, accelerated expansion makes it harder for clusters to pull new material inward. This leads to a universe that gradually becomes more settled and less active in large-scale structure formation, like a cosmic landscape that becomes quieter as time passes. The cosmic microwave background provides another calm connection. This ancient light has travelled since the early universe, filling space with a faint, nearly uniform glow. The patterns within it reveal information about the universe's geometry and composition, including dark energy. It is comforting to think of the cosmos leaving behind such a gentle record of its early state, like an afterglow that still quietly guides our understanding of expansion and the unseen energy shaping it. Perhaps the most restful truth is that dark energy remains an open mystery, but it is a peaceful one. It does not demand urgency or fear. It invites calm curiosity. The universe has been expanding for nearly 14 billion years, and dark energy has quietly become part of that unfolding story. Whether it is vacuum energy, a field, or something not yet understood, it continues to guide the cosmos outward in the most gentle way possible, allowing space to stretch slowly and steadily as galaxies drift farther into the quiet distance. Dark energy feels calm because it is something the universe does not need to display loudly. It does not appear as a bright object or a dramatic wave. Instead, it shows itself through the quiet behavior of distance over time, through the way space stretches gently and steadily across billions of years. Dark energy is known through patience, through careful observation of faraway galaxies, and through the soft truth that the universe's expansion is not slowing down the way gravity alone would suggest. A soothing detail is that dark energy does not interfere with the stability of your surroundings. The atoms in your body are held by electromagnetic forces that are immensely stronger than any effect of cosmic expansion. Your planet remains stable under gravity, the solar system stays bound, and the Milky Way continues to rotate calmly with its stars held together by gravity and dark matter. Dark energy becomes important only where the universe is most open, in the vast quiet spaces between galaxy clusters where gravity has less strength to hold everything together across enormous distances. The acceleration caused by dark energy is incredibly gentle in everyday terms. When scientists say the universe is accelerating, they mean the rate of expansion is increasing slowly over cosmic time. This is not a rapid surge, it is a subtle curve in the history of the universe. On the scale of a human lifetime, it is essentially stillness. The universe expands silently, and dark energy shapes that expansion with a steady influence that feels like a soft background pressure woven into space. One calming way to understand dark energy is through the image of a balloon with dots on its surface. As the balloon inflates, the dots move farther apart, not because the dots are travelling across the surface, but because the surface itself is stretching. In the same way, galaxies are not necessarily flying through space like objects in a wind. The space between them is expanding. Dark energy influences how quickly that expansion happens, and the result is a universe that slowly becomes more spacious, with distances widening gently and without sound. Dark energy is often modelled as the cosmological constant, which represents a constant energy density associated with empty space. This idea feels peaceful because it is stable and uniform. A cosmological constant does not create sudden changes. It does not form waves or clumps. It remains the same everywhere, acting as a smooth background feature of the universe. If this is the correct explanation, then dark energy is one of the calmest components of reality, always present, always even, always quietly shaping the largest scale motion. Scientists also explore the possibility that dark energy could change slowly over time, behaving like a dynamic field rather than a constant. Even in this scenario, the change would be extremely gentle. A field evolving across cosmic history would shift over billions of years, making its behavior smooth and gradual. It would feel like a slow drifting tide in the deepest ocean of space, changing just enough to influence expansion while remaining calm and subtle. Dark energy is measured through careful mapping of the universe's expansion history. Type Ia supernovae provide distance measurements, while baryon acoustic oscillations provide a cosmic ruler embedded in the distribution of galaxies. The cosmic microwave background provides a snapshot of the early universe's conditions. Together, these measurements create a consistent picture of a universe dominated by dark energy. The calm beauty here is that the cosmos leaves behind gentle patterns that can be read like a quiet record, allowing us to learn about unseen forces through light travelling across time. A peaceful truth about dark energy is that it shapes the future of the universe without urgency. If dark energy remains constant, the universe will continue expanding and accelerating forever. Over trillions of years, galaxies outside our local region will drift farther away, their light stretching and fading. This is not a sudden disappearance. It is a slow widening, like a gentle separation that increases quiet space between everything. The universe becomes more open, more still, and more calm. Dark energy also influences how large-scale structures evolve. In the early universe, gravity caused matter to gather into galaxies and clusters. As dark energy became dominant, accelerated expansion began to make it harder for gravity to form new, massive structures across vast distances. This does not mean structure stops forming completely. It means the universe gradually becomes quieter in its growth. It settles into a calmer state where existing structures remain, but the creation of new large-scale connections slows down. Perhaps the most restful thought is that dark energy remains mysterious, but not threatening. It is an open question that invites calm curiosity rather than fear. The universe has existed for nearly 14 billion years, expanding and evolving slowly, and dark energy appears as part of that long story. Whether it is vacuum energy, a hidden field, or something even more fundamental, it continues to guide the cosmos outward with steady patience, letting space expand gently, letting galaxies drift quietly, and allowing the universe to remain vast, open, and calm. Dark energy feels calming because it is not something that creates sharp events in the sky, but something that quietly shapes the universe in the background, almost like a slow rhythm built into space itself. It does not announce itself with bright flashes or loud signals. It does not gather into stars or planets. Instead, it is known through the most gentle evidence imaginable: the slow way galaxies drift farther apart, the subtle curve of cosmic expansion over billions of years, and the quiet realization that the universe is stretching faster now than it did long ago. A soothing truth is that dark energy does not disturb the stability of anything close to you. Your home, your city, your planet, and your solar system are all held together by forces that are far stronger than the expansion of space. Even galaxies are bound by gravity and remain intact. Dark energy becomes noticeable only in the widest, emptiest reaches of the universe, where gravity's grip weakens across enormous distances. This means dark energy belongs to deep space, where quiet already exists, and its influence is expressed as gentle widening rather than disruption. Cosmic expansion itself is a peaceful process to imagine. Galaxies are like distant islands of light, separated by enormous oceans of darkness. As time passes, the space between them stretches, and those islands slowly drift farther apart. Dark energy influences this stretching, encouraging it to accelerate. But even this acceleration is slow and smooth, unfolding over billions of years. There is no rush in it. The universe expands like a calm breath, steady and silent, measured not in seconds but in ages. A calm scientific insight is that dark energy appears to be smooth and evenly distributed, unlike matter, which clumps into galaxies and clusters. Matter creates texture in the universe, forming bright points and structured patterns. Dark energy seems to remain uniform, like an even background layer filling all of space. This smoothness makes it feel gentle, as though the universe has a quiet foundation beneath its visible structures, a soft presence that does not disturb the shapes that gravity has already formed. One of the simplest models for dark energy is the cosmological constant, which suggests dark energy is constant in time and space. This model is calming because it is stable and unchanging. A cosmological constant does not need complicated behavior. It does not fluctuate wildly. It remains steady, giving the universe a constant background energy that influences expansion. If this is true, dark energy is one of the most consistent features of reality, present everywhere, always quiet, always the same. Scientists also consider whether dark energy could be dynamic, slowly changing as the universe ages. This possibility would mean dark energy behaves like a field that evolves. Even so, its evolution would happen over immense spans of time, making it gentle by nature. A slowly changing dark energy would not create sudden shifts. It would be like a gradual drift in the deep background of the cosmos, so slow that it feels nearly constant, shaping expansion with soft persistence. Dark energy is measured through careful observations of distant supernovae and galaxy patterns. Type Ia supernovae provide a way to measure cosmic distances because their peak brightness is consistent. When distant supernovae appear dimmer than expected, it suggests the universe expanded more than predicted. This evidence is soothing because it comes from light traveling quietly across billions of years. The universe tells its story through faint signals, and dark energy appears as the gentle explanation behind those signals. Baryon acoustic oscillations, another key measurement, are like frozen ripples from the early universe, imprinted in how galaxies are spaced today, These ripples provide a cosmic ruler. By measuring how the ruler appears at different distances, scientists can track expansion across time. Dark energy affects this expansion history, subtly shaping the size and growth of cosmic distances. The calm beauty is that dark energy is revealed through patterns left behind by the universe's earliest moments, as if the cosmos carries gentle memory in its structure. The long-term future influenced by dark energy is quiet and gradual. If dark energy remains constant, expansion will continue accelerating and distant galaxies will drift beyond our observable reach. Their light will stretch into wavelengths too long to detect, fading into the background. This is not a sudden loss. It happens over trillions of years, like a slow dimming and widening. The universe becomes more spacious and more still, with larger quiet gaps between islands of matter. Perhaps the most restful thought is that dark energy remains mysterious without being urgent. The universe does not demand immediate answers. It continues expanding steadily whether we understand it fully or not. Dark energy represents a soft unknown, a calm question written into the fabric of space. It invites slow curiosity, gentle contemplation, and patient science. While the universe itself keeps stretching quietly, letting space widen smoothly, letting galaxies drift softly into deeper distance. Dark energy feels peaceful because it exists in the universe without needing to show itself directly. It does not glow like stars or reflect light like planets. It does not form shapes you can point to in the sky. Instead, it is known through the calmest kind of evidence, the gentle stretching of space over time, and the quiet observation that the universe is expanding faster now than it used to. Dark energy is like a soft presence in the background, influencing the larger scales of reality without ever becoming loud or sudden. A soothing truth is that dark energy does not pull apart the structures that matter has built. Galaxies remain bound by gravity. Stars remain stable inside their galactic neighborhoods. Solar systems continue their slow orbits, and planets remain secure. Dark energy is simply too weak to compete with these forces on small scales. It becomes noticeable only when you look at truly vast distances, where space is open enough for its gentle influence to show itself. It belongs to deep cosmic quiet, not to the crowded places where matter gathers. Cosmic expansion itself is a silent process, and dark energy shapes it in a way that stays smooth and gradual. Galaxies drift farther apart because the space between them expands, like an invisible fabric slowly stretching. This stretching is not something you would hear or feel. It is a change measured only with careful astronomy and long thought. Dark energy encourages this expansion to accelerate, but even that acceleration is delicate, unfolding across billions of years like a slow widening that never hurries. One calming scientific idea is that dark energy may be a constant property of space, often described as the cosmological constant. In this model, dark energy is uniform everywhere and does not change with time. It acts like a steady background density, quietly influencing the universe's expansion. The comforting part is its simplicity. A constant dark energy does not create complicated shifts or unpredictable behavior. It remains stable, giving the universe a smooth and consistent long-term pattern of expansion. Scientists also consider the possibility that dark energy could evolve over time, behaving like a dynamic field. Even in this case, the evolution would be extremely slow, so gradual that it would feel like near stillness. A changing dark energy would shift across cosmic history like a very slow tide, influencing expansion without accelerating sharp transitions. This keeps the idea gentle. Even the universe's deepest unknowns seem to move with patience. Dark energy is studied by building a map of the universe's expansion history. Type here supernovae serve as distance markers, offering a way to measure how far away galaxies are. Baryon acoustic oscillations provide a cosmic ruler, a fixed scale pattern in galaxy clustering that comes from sound waves in the early universe. The cosmic microwave background gives a snapshot of the universe's early conditions. Together, These methods create a calm, consistent picture of dark energy shaping expansion, not through one dramatic clue, but through many gentle patterns aligning. A peaceful detail is that dark energy became dominant relatively late in the universe's history. In the early universe, matter density was higher, and gravity slowed expansion. Over time, as the universe expanded, matter spread out and became less dense. Dark energy, if constant, did not dilute in the same way. Eventually it became the main influence on expansion. This shift is not a sudden takeover. It is a gradual change in balance, like a slow handover from one gentle influence to another over billions of years. Dark energy also influences the future growth of cosmic structures. Gravity continues to pull matter into clusters locally, but accelerated expansion makes it harder for new large-scale structures to form across enormous distances. Over time, the universe becomes more settled. The largest clusters remain, galaxies continue to exist within them, but the creation of new connections slows. This creates a future that is quieter and more still on the grandest scales, like a cosmic landscape that becomes calmer as it expands. In the far future, if dark energy stays constant, the universe will continue expanding indefinitely. Galaxies outside our local gravitational group will drift farther away and eventually become unreachable by light in practical terms, because their light will stretch and fade into wavelengths too long to detect. This is not an ending with a sudden boundary. It is a gentle fading into distance, a slow increase in quiet space between islands of matter. The universe becomes more spacious, more silent, and more open. Perhaps the most restful thought is that dark energy is a mystery that fits naturally into the universe's calmness. The cosmos does not need to be fully understood to be peaceful. Dark energy continues its gentle influence whether we solve it tomorrow or centuries from now. It is part of a universe that expands slowly and steadily, carrying light across billions of years, letting galaxies drift in silence, and allowing space itself to stretch outward with patient ease, as if the universe is simply unfolding in its own quiet time. Dark energy can feel calming because it is one of the universe's most steady influences, working so quietly that it only becomes visible when you look across unimaginable distances. It is not something you can point to directly, like a star or a planet. It is something you infer, like a soft truth hidden inside the motion of galaxies and the stretching of space. Dark energy is felt only in the gentle widening of the cosmos, the slow way the universe expands, and the quiet evidence that this expansion has been accelerating over long cosmic time. A soothing detail is that dark energy does not change the everyday stability of the universe around you. The forces that shape your life are far stronger. Electromagnetism holds atoms together and gives matter its form. Gravity holds planets, stars, and galaxies in steady structure. Dark energy is too weak to compete inside these bound systems. It becomes noticeable only where gravity fades across vast, empty regions between galaxy clusters, where space is wide enough for expansion to reveal itself clearly. The discovery of dark energy is a calm story of careful observation rather than sudden shock. Astronomers measure distant Type Ia supernovae, using them as cosmic distance markers because their brightness is predictable. When these distant supernovae appeared dimmer than expected, it meant they were farther away than predicted by a slowing universe. The simplest explanation was that space had expanded more than expected, suggesting acceleration. This discovery emerged from patient measurement and quiet statistical confidence, like the universe whispering its truth through faint light. Dark energy also appears in the way galaxies are distributed across the sky. Large surveys map billions of galaxies, revealing subtle patterns left over from the early universe. One of these patterns is baryon acoustic oscillations, a faint ripple in galaxy spacing that acts like a cosmic ruler. By measuring how this ruler looks at different distances, scientists trace the expansion history of the universe. Dark energy becomes part of the explanation for how that history curves toward acceleration, shaping the large-scale map with a gentle influence. A peaceful aspect of dark energy is that it seems smooth and evenly spread across space. Matter clumps into galaxies and clusters, creating bright structure. Dark energy, by contrast, does not appear to clump. It behaves like a uniform background, filling all of space evenly. This smoothness makes it feel like a quiet foundation beneath the visible cosmos, a gentle presence that does not create turbulence or sharp boundaries, only a steady background effect. In general relativity, dark energy can be understood as a form of energy that has negative pressure. Negative pressure sounds strange, but its meaning is subtle. It is not pressure like pushing on a surface. It is pressure in the cosmic sense, a property of the universe's energy content that affects how space expands. Dark energy's negative pressure leads to accelerated expansion, but in a calm way, as if the universe has a slight tendency to stretch outward more strongly as time goes on. One of the simplest models for dark energy is the cosmological constant, which assumes its density stays the same everywhere and does not change over time. This is soothing because it means dark energy is stable and predictable, not fluctuating or sudden. The cosmological constant makes the future expansion of the universe smooth and steady, with acceleration continuing gently without sharp surprises. It paints the cosmos as something with a quiet, consistent background rule built into it. Another possibility is that dark energy might evolve slowly, like a dynamic field. This idea is sometimes called quintessence. Even here, the behavior would still be gentle. A changing field would shift over cosmic timescales, not quickly. The universe would still expand smoothly. The differences would appear only when comparing billions of years of history, making dark energy feel like a soft drift rather than an active force, like a slow current in deep space. Dark energy also influences the far future of cosmic visibility. As expansion accelerates, galaxies beyond our local group drift farther away. Their light stretches to longer wavelengths, becoming dimmer and more difficult to detect. Over very long times, many distant galaxies will fade from view entirely. This is not a sudden disappearance. It is a slow retreat into distance, like islands gradually sinking beyond the horizon in an endless ocean, leaving more open dark space in between. Perhaps the most restful thought is that dark energy is a mystery that does not demand urgency. The universe is patient. It has unfolded for nearly 14 billion years, and it will continue unfolding for far longer. Dark energy may remain unknown for a time, but its influence remains calm and steady, guiding the expansion of space in a gentle way. Even without full understanding, the universe continues widening softly, letting galaxies drift quietly apart, allowing the cosmos to remain vast, open, and slow in its endless, peaceful motion. Dark energy can feel comforting because it is not something that interrupts the universe, but something that quietly belongs to it. It does not arrive from outside. It does not surge like a wave. It seems to be present everywhere, woven into space itself as a gentle background influence. Dark energy reveals itself through the slow widening of the cosmos, through the soft truth that the universe is expanding, and through the even softer realization that this expansion is gradually accelerating over billions of years in a way that remains smooth and steady. A soothing detail is that dark energy does not pull on you, your planet, or even your galaxy in any noticeable way. The atoms in your body remain bound by electromagnetic forces that are overwhelmingly stronger than cosmic expansion. Gravity holds Earth together and holds the Moon in orbit. Gravity and dark matter hold the Milky Way together, keeping its stars in their slow rotations. Dark energy becomes noticeable only in the most open stretches of space, where matter is sparse and gravity's ability to gather things is weaker across enormous distances. The universe expands in a way that is often best understood as the expansion of space itself, not as galaxies moving through space like objects through air. Galaxies can be thought of as resting in space while the distances between them grow. This is like points on a stretching fabric, or dots on a slowly inflating surface. Dark energy affects how quickly that stretching happens over time. The calming part is that nothing is racing. Space is simply widening gently, and the universe becomes more spacious without any need for forceful motion. The evidence for dark energy comes from quiet measurements. Type I supernovae, which are explosions of white dwarf stars reaching a predictable brightness, act as distance markers across the cosmos. When astronomers measured these supernovae far away, they found the distant universe looked more expanded than expected. The supernovae appeared dimmer, meaning they were farther than a slowing expansion would predict. This gentle mismatch, repeated across many observations, revealed a calm but profound conclusion. Expansion is accelerating. Dark energy is also supported by the patterns of galaxy clustering. The universe contains a faint preferred scale in the spacing of galaxies called baryon acoustic oscillations, which are remnants of sound waves in the early universe. These patterns act like a cosmic measuring stick, allowing scientists to track how distances have changed. Dark energy becomes part of the explanation for why the universe's expansion history curves toward acceleration, shaping the large-scale structure of space without ever producing a visible object. A peaceful idea is that dark energy seems smooth and uniform. Matter clumps, forming galaxies, stars, planets, and all the visible texture of the cosmos. Dark energy does not appear to clump in the same way. It acts like a steady background density spread evenly through space. This smoothness makes it feel like the universe has this quiet foundation that remains consistent, while matter forms islands of structure within a larger ocean of calm emptiness. In the language of general relativity, dark energy can be described as having negative pressure. Negative pressure is a strange concept, but it can be understood gently as a property that causes space to expand faster over time. It is not pressure you would feel pressing against your skin. It is pressure as part of the universe's energy content, influencing the geometry of space-time. The calmness comes from its steadiness. This effect does not produce sudden changes, it simply shifts the expansion rate slowly and smoothly across cosmic history. The simplest model of dark energy is the cosmological constant, which assumes the density of dark energy does not change over time. If dark energy is constant, then it remains the same in every region of space, no matter how much the universe expands. This creates a future where acceleration continues steadily, and cosmic expansion becomes a smooth, predictable feature of the universe's long-term behavior. The simplicity of this model feels soothing, as if the universe carries a quiet rule within it that never needs to vary. Another possibility is that dark energy evolves slowly, behaving like a dynamic field such as quintessence. Even this model remains calm in character because any evolution would happen over billions of years. The field would drift slowly through values, changing the expansion rate gently rather than sharply. It is like imagining the universe's background influence shifting gradually, so gently that only the widest spans of time could reveal the difference. Dark energy shapes the far future of cosmic visibility. As expansion accelerates, galaxies outside our local gravitational region will drift farther away. Their light will stretch to longer wavelengths, becoming dimmer and more difficult to detect. Over very long periods, the universe will appear emptier, with fewer distant galaxies visible. This is not a sudden change. It is a slow fading into distance, like a horizon slowly moving outward until only nearby structures remain. Perhaps the most restful truth is that dark energy is a quiet mystery that fits perfectly into the universe's slow nature. It does not demand urgency. The cosmos has always unfolded patiently. Dark energy has been influencing expansion for billions of years, and it will continue shaping the universe long into the future. Whether it is vacuum energy, a dynamic field, or something deeper still unknown, its influence remains gentle, guiding space outward in a steady, calm expansion that continues silently, smoothly, and endlessly through time. Dark energy can feel calming because it is not a sudden event in the universe, but a slow and steady influence that seems to exist everywhere, quietly shaping the way space expands. It does not form bright objects or dramatic clouds. It does not announce itself with sound. Instead, it appears in the long, gentle story of cosmic distance, in the way galaxies drift farther apart, and in the soft truth that the universe's expansion has been accelerating over billions of years, as if space itself is slowly relaxing outward. A soothing truth is that dark energy does not disturb the stability of the things closest to you. The forces that hold matter together are much stronger on small scales. Electromagnetic attraction keeps atoms bound. Gravity holds planets, stars, and galaxies in stable arrangements. Dark energy is far too weak in these regions to create noticeable effects. It becomes visible only across vast empty stretches of space where gravity is thinly spread and cosmic expansion becomes the dominant influence, giving dark energy a home in the quietest parts of the universe. One calm way to understand dark energy is to see it as connected to the vacuum of space itself. In physics, empty space is not truly empty. Fields fill the universe, and even in their lowest energy states, they can contain subtle energy. If dark energy is vacuum energy, then it is not something moving through space, but something inherent to space. This idea is soothing because it makes emptiness feel gentle and alive in a quiet way, carrying a small, steady energy that shapes the larger scale behavior of the cosmos. The acceleration of the universe's expansion is revealed through measurements that are themselves calm and patient. Type Ia supernovae serve as cosmic distance markers because their brightness is predictable. When astronomers observed distant supernovae, they found they were dimmer than expected, meaning they were farther away. This indicated that the universe had expanded more than a slowing universe would predict. The discovery of dark energy came from this quiet mismatch, not from one single dramatic observation, but from a careful pattern found through repeated study. Galaxy surveys provide another peaceful clue. The universe contains a faint pattern called baryon acoustic oscillations, an imprint from sound waves in the early universe that became frozen into the distribution of galaxies. This pattern acts like a cosmic ruler. By measuring it at different distances, scientists see how the universe has expanded over time. Dark energy enters as the gentle explanation for why that expansion appears to accelerate, shaping distances without creating visible objects. The cosmic microwave background, the faint afterglow of the early universe, offers a calm window into the universe's composition. It is ancient light that has been travelling for nearly the entire history of the cosmos. Tiny temperature variations in this background light reveal information about the geometry of the universe and the balance of its components, including dark energy. It is comforting to know that the earliest light still carries quiet information that helps us understand the universe's present expansion. Dark energy is often described as smooth and uniform, unlike matter, which clumps into galaxies and clusters. Matter forms structure, creating the visible texture of the cosmos. Dark energy seems to remain evenly spread, acting like a calm background. This smoothness feels restful because it suggests that the universe is not dominated by harsh unevenness, but by a soft, steady component that does not gather or collide, only quietly influences the overall stretching of space. In the language of cosmology, dark energy can be described using an equation of state parameter that relates pressure to energy density. For a cosmological constant, this parameter equals -1, meaning the pressure is negative. Negative pressure sounds strange, but it creates a gentle effect in general relativity, encouraging space to expand faster. The calmness comes from how smooth this behavior is. There are no sudden forces or shocks, only a steady tendency for expansion to continue and slowly accelerate. Dark energy became dominant relatively late in cosmic history. In the early universe, matter and radiation were denser, and gravity worked to slow expansion. As space expanded, matter spread out, becoming less dense. If dark energy remains constant, it does not dilute in the same way. Over billions of years, dark energy gradually became the strongest influence on expansion. This shift is calm because it is gradual, like a slow change in balance where one component becomes more noticeable as another fades. Perhaps the most restful way to think about dark energy is to see it as the universe's long-term quiet guide. It shapes the future without urgency. If dark energy remains constant, expansion will continue accelerating and distant galaxies will slowly drift beyond our observable reach. Their light will stretch and fade over trillions of years, leaving a universe that is more spacious and more silent. This is not a sudden ending. It is a gentle widening, a calm unfolding of space into greater openness, where the cosmos continues expanding softly, carrying its mysteries quietly through time. Dark energy can feel especially calming when you imagine it not as a thing moving through the universe, but as a quiet feature of the universe itself, like a gentle background condition that never needs to rush. It does not form visible shapes or bright structures. It does not clump like matter. It remains smooth, subtle, and present everywhere, revealing itself only through the slow way space expands across the largest distances and through the patient evidence that the universe's expansion has been accelerating over cosmic time. A soothing truth is that dark energy does not compete with the forces that shape your daily world. The atoms in your body remain bound because electromagnetism is incredibly strong on small scales. Gravity keeps Earth stable, keeps the moon in orbit, and keeps planets moving around the sun in calm, repeating paths. Even the Milky Way remains held together by gravity and dark matter. Dark energy becomes noticeable only where space is vast and matter is thin in the quiet distances between galaxy clusters, where expansion has room to express itself gently. One calm way to understand dark energy is to think of the universe expanding like a fabric slowly stretching. Galaxies are like points embedded in that fabric. They do not need to travel like objects moving through air. The space between them is what grows. Dark energy affects how quickly this cosmic fabric stretches over time. It does not create a sudden tear or snap. It is more like a slow loosening, a steady widening that happens everywhere at once, quietly changing the scale of the universe without disturbing local stability. The evidence for dark energy comes from careful observation of distant Type Ia supernovae, which act as cosmic distance markers because they reach a predictable brightness. When astronomers measured these supernovae in faraway galaxies, they found them dimmer than expected. This meant they were farther away than predicted by a universe whose expansion was slowing. The simplest explanation was that the universe had expanded more than expected, implying acceleration. This discovery was calm in nature, emerging from faint light and quiet data, rather than from any sudden visible event. Dark energy is supported by galaxy surveys that measure how matter is distributed across the universe. Within these distributions, scientists find baryon acoustic oscillations, faint patterns left by sound waves in the early universe. These patterns act like a cosmic ruler, allowing researchers to track how distances have changed over time. Dark energy influences those distances, shaping the expansion history in a smooth way, like a gentle hand guiding the universe's growth without needing to be seen. The cosmic microwave background offers another peaceful clue. It is the oldest light we can observe, released when the universe was still young and hot. Today it fills space as a faint microwave glow, nearly uniform in every direction. Tiny variations in this glow carry information about the universe's geometry and composition. Dark energy affects the universe's evolution after that light was released, influencing how space expanded and how structures formed, leaving its subtle imprint on the way we interpret that ancient background. Dark energy appears to be smooth and uniform, unlike matter which gathers into galaxies and clusters. Matter creates bright islands of structure. Dark energy seems to remain spread out evenly, like a calm ocean beneath those islands. This smoothness is comforting because it suggests that the universe's dominant component is not chaotic or turbulent, but steady and consistent, a quiet presence that influences the whole without breaking into pieces. In the framework of general relativity, dark energy can be associated with negative pressure, which leads to accelerated expansion. Negative pressure does not mean suction or pulling inward the way it might sound. It is a property of the energy content of space that affects how space-time evolves. The calmness comes from how gradual the effect is. Dark energy does not force the universe into sudden changes. It simply bends the long-term expansion curve, shaping the universe's future in a gentle way. As dark energy becomes dominant, the growth of large-scale structures slows. Gravity still pulls matter together locally, forming galaxies and clusters, but accelerated expansion makes it harder for new massive structures to form across vast distances. Over cosmic time, the universe becomes quieter in its large-scale evolution. Existing structures remain, but the creation of new ones becomes less frequent. This gives the cosmos a settling quality, like a landscape that becomes more still as it expands. Perhaps the most restful way to hold dark energy in your mind is as a calm mystery that matches the universe's slow nature. It does not demand urgency. It has been shaping expansion for billions of years, and it will continue shaping it far into the future. Whether it is vacuum energy, a dynamic field, or something not yet understood, its influence remains steady and smooth. Space continues widening gently. Galaxies drift farther apart in silence, and the universe becomes more open, more spacious, and more quiet, unfolding with patient ease across time. Dark energy can feel calming because it is one of the universe's most patient influences, quietly shaping cosmic expansion without needing to create a visible object or a dramatic event. It does not appear as a bright point in the sky. It does not gather into clouds or form structures the way matter does. Instead, it seems to live in the background of space itself, revealing its presence through the gentle widening of distances between galaxies over billions of years, as if the universe has a slow and steady tendency to stretch outward more strongly with time. A soothing truth is that dark energy does not disturb the stable systems close to you. Atoms remain intact because electromagnetic forces bind them together. Planets and moons remain in their orbits because gravity holds them in a predictable dance. Galaxies remain stable because gravity, supported by dark matter, keeps their stars and gas bound together. Dark energy becomes noticeable only in the most open and distant regions of the cosmos, where matter is thin and gravity's pull across immense distances becomes weaker, leaving room for cosmic expansion to show its quiet effect. The idea of cosmic acceleration can sound intense, but the actual process is gentle and slow. Expansion happens at a rate that is almost still on human timescales. Even the acceleration itself is measured across billions of years, meaning it is a soft curve in the universe's history rather than a sharp change. Dark energy is not like a sudden push. It is more like a constant presence that shifts the universe's long-term behavior, encouraging space to widen smoothly and persistently in the calmest way possible. One peaceful way to imagine dark energy is through the idea of space as a fabric that can stretch. Galaxies are like distant markers embedded in that fabric. As the fabric stretches, the markers move farther apart, not because they are racing across it, but because the surface itself is expanding. Dark energy influences this stretching, shaping how the scale of the universe changes with time. The comforting part is that the expansion is silent, smooth, and uniform, like a slow unfolding that continues without urgency. Dark energy was first revealed through the careful study of distant type Ia supernovae, which act as distance markers because they reach a predictable brightness. When astronomers observed these supernovae in faraway galaxies, they found them dimmer than expected, suggesting that the galaxies were farther away than they should have been in a universe slowing down. The simplest explanation was that expansion had accelerated. This discovery came through quiet light travelling across billions of years, showing dark energy as a gentle clue hidden in faint brightness. Other evidence comes from the distribution of galaxies across space. The universe contains a subtle pattern called baryon acoustic oscillations, a remnant of sound waves from the early universe. This pattern provides a cosmic ruler. By measuring this ruler at different distances, scientists can track how expansion has changed. Dark energy shapes this history, affecting how distances grow. The calm beauty here is that the universe carries gentle echoes of its earliest moments, and dark energy becomes part of the explanation when those echoes are read carefully. The cosmic microwave background, the oldest light we can see, also helps reveal dark energy. It fills space as a faint microwave glow from the early universe. Tiny patterns in this background light help determine the universe's geometry and composition. Dark energy influences how the universe evolved after this light was released, affecting how structures formed and how expansion changed. It is comforting to know that even the universe's earliest light still holds information that guides our understanding of its quiet expansion today. Dark energy appears smooth and uniform, matter clumps forming galaxies and clusters, creating texture in the cosmos. Dark energy does not seem to clump in the same way. It stays evenly spread, like a calm ocean beneath the islands of matter. This smoothness makes dark energy feel gentle because it suggests the dominant component of the universe is not chaotic or sharply structured, but steady and consistent, a quiet presence that fills space evenly. As dark energy becomes more dominant, it influences the future growth of structures. Gravity still forms galaxies and clusters locally, but accelerated expansion makes it harder for new large-scale structures to form across vast distances. Over time, the universe becomes calmer in its large-scale development. Existing structures remain, but the formation of new connections slows. This creates a future that is quieter and more settled, not through sudden endings, but through gradual change. Perhaps the most restful thought is that dark energy remains mysterious without being threatening. It is a quiet unknown that fits naturally into the calm nature of the cosmos. The universe has expanded for nearly 14 billion years, and dark energy has quietly become part of that unfolding story. Whether it is vacuum energy, a dynamic field, or something even deeper, its influence remains smooth and steady. Space continues stretching outward gently. Galaxies drift farther apart in silence, and the universe becomes more open and spacious, unfolding with patient calm across immeasurable time. Dark energy can feel calming because it behaves like the universe's quiet background rhythm, steady and subtle, shaping the largest scales of space without ever needing to form a visible object. It does not glow, it does not cast shadows, and it does not gather into clusters. Instead, it appears as a gentle influence on the expansion of the cosmos, revealed only through the slow movement of galaxies away from one another over billions of years, as if space itself carries a soft tendency to stretch outward more strongly as time passes. A soothing truth is that dark energy does not disturb the stable structures close to you. The atoms in your body remain tightly bound by electromagnetic forces. Earth remains stable under gravity, held together as a single world. The solar system continues its calm orbits, and the Milky Way remains intact, its stars moving through predictable paths shaped by gravity and dark matter. Dark energy becomes noticeable only on the largest scales, where distances are so vast that gravity between faraway structures is weaker, allowing expansion to express itself gently in the open spaces between galaxy clusters. The universe's expansion is often described using the idea of a scale factor, a way of measuring how the size of the universe changes with time. Dark energy influences how that scale factor evolves, shaping the curve of expansion history. What makes this peaceful is that it is slow. The expansion does not leap forward. It does not shift suddenly in a single moment. It unfolds smoothly over cosmic time like a gentle stretching of the universe's fabric that continues with patience. Dark energy was first discovered through distant Type Ia supernovae, which are useful as distance markers because their peak brightness is predictable. When astronomers compared supernova brightness across large distances, they found that very distant supernovae appeared dimmer than expected, meaning they were farther away than a slowing universe would predict. This suggested the universe had expanded more than anticipated, implying acceleration. The calmness of this discovery lies in its nature. It was not a sudden visible event, but a quiet pattern that emerged through careful observation and gentle statistical certainty. Galaxy surveys provide another peaceful clue through baryon acoustic oscillations, a pattern in the spacing of galaxies that comes from sound waves in the early universe. This pattern acts like a cosmic ruler. By measuring how that ruler appears at different distances, scientists can see how the expansion of the universe has changed over time. Dark energy influences those distances in a subtle way, shaping the expansion history smoothly, like a quiet hand guiding the universe outward without making itself visible. The cosmic microwave background, the faint afterglow from the early universe, also supports the existence of dark energy. It fills all of space as a soft microwave glow, nearly uniform in every direction. Tiny variations within it provide information about the universe's geometry and composition. Dark energy affects the universe's later expansion and structure formation, influencing how we interpret the patterns seen in this ancient light. It is comforting to know that even the oldest light still carries gentle information that helps explain the universe's calm expansion today. Dark energy appears to be smooth, unlike matter which clumps into galaxies and clusters. Matter forms structure, creating the visible texture of the cosmos. Dark energy seems to remain evenly spread, like a calm ocean filling the space between these structures. This smoothness feels restful because it suggests the universe is dominated by something steady and uniform rather than chaotic. Dark energy does not create sharp boundaries or turbulence. It simply exists everywhere, quietly influencing expansion. As dark energy becomes dominant, it slows the growth of very large structures. Gravity still works locally, keeping galaxies bound and clusters stable. But on the larger scales, accelerated expansion makes it harder for gravity to pull matter together across immense distances. Over time, the universe becomes quieter in its large-scale evolution. Structure still exists, but formation of new giant clusters and connections slows. The cosmos settles into a calmer pattern, like a landscape that becomes more still as space widens. In the far future, if dark energy remains constant, the universe will continue expanding and accelerating. Distant galaxies will drift farther away, and their light will stretch to longer wavelengths, becoming faint and eventually undetectable. This is not a sudden disappearance, it is a slow fading over trillions of years, like islands of light gently slipping beyond a distant horizon, leaving behind more open, dark space between the remaining structures. Perhaps the most restful thought is that dark energy is a mystery that feels peaceful because it fits the universe's slow nature. It does not demand urgency. It has been shaping expansion for billions of years, and it will continue shaping the universe far into the future. Whether it is vacuum energy, a dynamic field, or something deeper still unknown, its influence remains gentle, steady, and smooth. Space continues stretching outward quietly. Galaxies drift softly apart, and the universe keeps unfolding with calm patience across time. Dark energy can feel calming because it is one of the universe's most gentle influences, working quietly in the background of space itself. It does not appear as a bright object or a moving cloud, and it does not create sudden events. Instead, it reveals itself through the slow expansion of the universe, through the way distances between galaxies increase over time, and through the subtle evidence that this expansion has been accelerating for billions of years. Dark energy feels like a soft, steady presence, not demanding attention, but shaping the cosmos with patient consistency. A soothing truth is that dark energy does not affect the stability of things close to you. The atoms in your body remain secure because electromagnetic forces bind them tightly. Earth remains whole because gravity holds it together. The solar system stays stable with planets moving along predictable orbits. Even galaxies remain bound by gravity and dark matter. Dark energy becomes noticeable only on enormous scales, where matter is sparse and gravity's pull across vast distances becomes weaker, allowing expansion to become the dominant behavior. The universe's expansion is often best imagined as the stretching of space itself. Galaxies are not necessarily flying outward through space like objects in a wind. Instead, they are carried apart as space expands between them. This is like dots on an inflating balloon, where the dots themselves stay in place relative to the surface but still move farther apart as the surface stretches. Dark energy influences how quickly this stretching happens over time. The calm part is that it is silent, smooth, and uniform, a gentle widening rather than a sudden motion. Dark energy was discovered through careful observation of a distant type Ia supernovae, which are used as distance markers because they have a predictable brightness. When astronomers observed supernovae far away, they found them dimmer than expected, meaning the universe had expanded more than predicted by gravity alone. This implied that expansion had accelerated. The discovery was quiet, based on faint light travelling for billions of years and patient measurements that gradually revealed a consistent pattern, as though the universe's expansion was quietly telling its own story. Galaxy surveys provide another gentle clue through baryon acoustic oscillations, patterns in the distribution of galaxies that come from sound waves in the early universe. These patterns act like a cosmic ruler. By measuring this ruler across different distances, scientists track how the expansion of the universe has changed over time. Dark energy influences these measurements in a subtle way, shaping the cosmic distance scale smoothly, like a steady background influence guiding the universe's growth. The cosmic microwave background, the oldest light we can observe, also supports the existence of dark energy. This ancient glow fills space in microwave wavelengths, nearly uniform across the sky. Tiny variations in this background reveal information about the universe's geometry and composition. Dark energy affects how the universe evolved after this light was released, influencing expansion and structure formation. It is comforting that the universe's earliest light still carries gentle evidence of the calm forces shaping it today. Dark energy seems smooth and evenly spread across space, unlike matter which clumps into galaxies and clusters. Matter forms visible structures, creating texture in the cosmos. Dark energy does not appear to clump or form lumps. It behaves like a uniform background that fills all of space. This smoothness makes it feel restful, as though the universe is dominated by something quiet and consistent, not sharp or chaotic, but steady and evenly present everywhere. As dark energy becomes more dominant, it slows the growth of large-scale cosmic structures. Gravity still holds galaxies and clusters together locally, but accelerated expansion makes it harder for new structures to form across great distances. Over time, the universe becomes calmer in its large-scale evolution. Existing structures remain, but the formation of new massive connections becomes less likely. This creates a future that is spacious and settled, shaped by gradual quiet change rather than dramatic transformation. If dark energy remains constant, the universe will keep expanding and accelerating far into the future. Galaxies outside our local gravitational neighborhood will drift farther away, their light stretched into longer wavelengths, becoming faint. Over very long times, many distant galaxies will fade from view, leaving a universe that appears emptier and quieter. This is not a sudden ending. It is a slow fading, a gentle widening that increases calm space between islands of matter. Perhaps the most restful thought is that dark energy remains a mystery without being threatening. It invites quiet curiosity rather than fear. The universe is patient. It has been expanding for nearly 14 billion years, and dark energy has quietly become part of that unfolding story. Whether it is vacuum energy, a dynamic field, or something deeper still unknown, its influence remains smooth and gentle. Space continues stretching outward silently. Galaxies drift softly apart, and the cosmos keeps expanding with calm persistence across time. Dark energy feels peaceful because it does not behave like an object with edges, motion or noise. It is not a cloud drifting through space, and it is not a force you would feel pressing against anything nearby. It seems to be a quiet property of the universe itself, revealed only through the slow, steady expansion of space. Dark energy becomes visible in the calmest way possible, through the gentle story told by distant galaxies whose light has travelled for billions of years, carrying the evidence that the universe is expanding faster now than it once did. A soothing truth is that dark energy is almost completely irrelevant on small scales, which means it does not interfere with the stability of the world around you. The atoms in your body remain securely bound by electromagnetic forces. Gravity holds Earth together and holds the solar system in steady motion. Even galaxies remain intact, their stars orbiting calmly under gravity's influence. Dark energy only becomes important when you look at the widest scales imaginable, where the universe is so open and vast that gravity between distant regions becomes weak enough for expansion to dominate. The expansion of the universe is often misunderstood as galaxies racing outward, like objects thrown from an explosion, but the calmer and more accurate view is that space itself is stretching. Galaxies can be thought of as resting within that space, while the distance between them grows. This is like dots painted on a rubber sheet that slowly expands, causing the dots to separate without needing to move across the surface. Dark energy influences how quickly this expansion grows with time, shaping the universe's long-term behavior without creating sharp motion or disturbance. Dark energy was first discovered through distant Type Ia supernovae, which are valuable because they reach a predictable peak brightness. By comparing their observed brightness with their redshift, astronomers can estimate their distance and see how expansion has changed. When very distant supernovae appeared dimmer than expected, it suggested that the universe had expanded more than gravity alone would predict. The conclusion was quiet and profound. The expansion is accelerating. This discovery emerged not from one loud signal, but from careful repetition, steady data, and a gentle curve in the universe's expansion history. Baryon acoustic oscillations offer another peaceful clue. These are subtle patterns in galaxy clustering, left behind by sound waves travelling through the early universe's hot plasma. Over time, these ripples became frozen into the distribution of matter, leaving a faint preferred scale. By measuring the scale at different distances, scientists track how expansion has unfolded. Dark energy influences these measurements, gently shaping how cosmic distances grow, like a quiet hand guiding space to stretch more strongly with time. The cosmic microwave background, the oldest light we can observe, carries calm evidence as well. It is a faint glow left from when the universe cooled enough for light to travel freely, long before stars and galaxies fully formed. The patterns in this ancient light reveal information about the universe's geometry and composition. Dark energy affects the later expansion of space and the growth of structure, meaning its presence is part of the larger story that connects the earliest light to the universe we see today. Dark energy seems smooth and uniform, unlike matter, which clumps and forms structure. Matter gathers into galaxies, clusters and filaments, creating texture in the cosmos. Dark energy does not form these visible patterns, it appears evenly spread, like a calm ocean filling all of space. This smoothness feels restful because it suggests that the dominant component of the universe is not chaotic or uneven, but steady and consistent, present everywhere with no sharp boundaries. As dark energy becomes dominant, it slows the formation of new large-scale cosmic structures. Gravity still works locally, keeping galaxies bound and clusters stable, but across vast distances, accelerated expansion makes it harder for gravity to pull matter together into new, large structures. Over time, the universe becomes quieter in its growth. Existing structures remain, but the creation of new connections between distant regions slows. This leads to a future that is more spacious and settled, shaped by gradual calmness. If dark energy remains constant, the universe will continue expanding and accelerating far into the future. Distant galaxies will drift farther away, their light stretched into longer wavelengths and becoming increasingly faint. Over trillions of years, many galaxies will fade beyond detection, leaving a universe that appears emptier and more quiet. This is not a sudden disappearance. It is a slow, widening and soft fading, like distant lights gradually slipping beyond a horizon. Perhaps the most restful thought is that dark energy remains a peaceful mystery. The universe does not demand an immediate answer. Dark energy has been shaping cosmic expansion for billions of years, and it will continue shaping the future whether or not we understand it fully. It invites calm curiosity, patient observation, and gentle reflection. In the background, space continues stretching outward quietly. Galaxies drift softly apart and the cosmos keeps unfolding with steady, silent expansion across time. Dark energy can feel calming because it is not something that appears suddenly in the universe, but something that seems to be quietly present at all times, like a gentle background condition woven into the fabric of space. It does not shine, it does not scatter light, and it does not gather into objects. Instead, it reveals itself through the slow expansion of the universe, through the way space stretches over billions of years, and through the subtle evidence that this expansion has been accelerating, as if the cosmos is gradually opening wider with steady patience. A soothing truth is that dark energy does not disturb the stable systems around you. The electromagnetic force keeps atoms bound and gives matter its solid form. Gravity keeps planets, moons, and stars moving in calm orbits, and it holds galaxies together in long-lasting structure. Dark energy is far too weak to overcome these forces on small scales. Its influence becomes meaningful only across the vastest distances, where matter is sparse and gravity's pull between faraway regions is diluted, allowing cosmic expansion to become the dominant behavior. The idea of cosmic acceleration can sound intense, but the real process is gentle. The universe does not suddenly speed up in a dramatic burst. Instead, the rate of expansion increases slowly over time, a change so gradual that it can only be measured across billions of years. On human timescales, the universe's expansion feels like stillness. Dark energy guides the expansion in a smooth way, shaping the cosmos with a quiet consistency, like a slow widening breath that continues without hurry. A calm way to picture expansion is to imagine galaxies as markers in a stretching fabric. They are not necessarily flying outward through space. It is the space between them that grows. As that space expands, light travelling through it also stretches, shifting toward longer wavelengths in a process called redshift. Dark energy influences the expansion rate, and therefore influences how much light stretches over time. This connection feels soothing because it turns a deep mystery into something gentle and observable, a quiet stretching of ancient light that carries information across the universe. Dark energy was first discovered through the careful measurement of distant type Ia supernovae. These supernovae act as cosmic distance markers because they reach a predictable brightness. When astronomers observed these explosions far away, they found they were dimmer than expected, meaning they were farther away than predicted by a universe slowing down under gravity alone. This suggested the universe had expanded more than expected, and therefore expansion had accelerated. The discovery emerged calmly from faint light and careful analysis, not from any sudden dramatic event. Baryon acoustic oscillations provide another peaceful clue. These are patterns in the distribution of galaxies, left behind by sound waves that travelled through the hot plasma of the early universe. Those sound waves created a preferred separation scale, which still appears faintly in galaxy clustering today. By measuring this pattern at different cosmic distances, scientists track how expansion has unfolded. Dark energy shapes that unfolding, influencing how distances grow across time in a smooth and steady way. The cosmic microwave background, the universe's oldest light, also helps confirm the existence of dark energy. This faint microwave glow fills space nearly evenly, carrying tiny temperature variations that reveal information about the universe's early conditions. Dark energy affects the later evolution of space, influencing geometry and structure growth. The soothing part is that the universe contains these quiet records, like a cosmic memory, allowing us to study unseen forces by listening carefully to ancient light. Dark energy appears to be smooth and evenly distributed, unlike matter which clumps into galaxies and clusters. Matter forms the visible structure of the universe, creating bright islands of stars and gas. Dark energy does not form islands, it acts like a calm ocean that fills all of space. This smoothness is comforting because it suggests that the dominant energy component of the cosmos is not chaotic or turbulent, but quiet and uniform, steady in its presence everywhere. As dark energy becomes dominant, the growth of new large-scale structure slows. Gravity still binds matter locally, keeping galaxies and clusters stable, but accelerated expansion makes it harder for gravity to pull distant matter into new, massive structures. Over time, the universe becomes quieter in its large-scale development. Existing structures remain, but the formation of new connections becomes less frequent. The cosmos gradually settles into a calmer pattern, where space grows larger and emptier between the same islands of matter. Perhaps the most restful thought is that dark energy shapes the future in a gentle way. If it remains constant, expansion will continue accelerating, and distant galaxies will drift beyond our observable reach over trillions of years. Their light will stretch and fade, not suddenly but gradually, like distant lanterns disappearing into a widening fog. The universe becomes more spacious, more silent, and more open. Dark energy remains there, steady and smooth, guiding expansion quietly onward, inviting calm curiosity while the cosmos continues its patient unfolding across time. Dark energy can feel peaceful because it is not something that disrupts the universe, but something that quietly belongs to it, like a soft background condition that has always been there in some form. It does not arrive as a visible object, and it does not express itself through sharp events. Instead, it reveals itself through the slowest and calmest motion the universe can offer, the gentle stretching of space over billions of years, and the subtle evidence that this stretching has been accelerating, as if the cosmos is gradually opening wider with steady patience. A soothing truth is that dark energy does not affect the stability of the world close to you. Atoms remain bound because electromagnetic forces are overwhelmingly strong on small scales. Gravity holds Earth together and keeps planets moving in calm orbits. The solar system remains stable, and galaxies remain intact, held by gravity and dark matter. Dark energy is far too weak to pull these systems apart. Its influence becomes important only across the largest distances, where matter is sparse and gravity between faraway regions becomes diluted, allowing expansion to become the dominant behavior. The universe expands not like an explosion throwing galaxies outward, but like space itself stretching. Galaxies can be thought of as resting in that space, while the distances between them grow. This is like points on a rubber sheet that slowly expands, causing the points to separate without moving across the surface. Dark energy influences this stretching, shaping how the universe's scale changes with time. The calmness is in the uniformity. Expansion happens everywhere, smoothly, silently, and without sharp edges. Dark energy was discovered through careful measurements of distant Type Ia supernovae, which are used as cosmic distance markers because their peak brightness is predictable. When astronomers observed very distant supernovae, they found them dimmer than expected, meaning they were farther away than predicted in a universe slowing down under gravity alone. This suggested that the universe had expanded more than expected, implying acceleration. The discovery came not from a single dramatic moment, but from repeated observations and gentle statistical confidence, as if the cosmos revealed its truth through patience. Another calm clue comes from baryon acoustic oscillations, patterns in galaxy distribution that act like a cosmic ruler. These patterns originated as sound waves in the early universe's hot plasma, leaving behind a preferred separation scale in the distribution of matter. By measuring this scale at different distances, scientists can map expansion history. Dark energy shapes that history, influencing how distances grow over time in a smooth and steady way, like a quiet hand guiding the universe outward. The cosmic microwave background, the oldest light in the universe, offers another peaceful connection. It fills space with a faint microwave glow, carrying tiny variations that reveal information about the universe's geometry and composition. Dark energy affects the later expansion of the universe and the growth of structure, meaning its presence is part of the story that connects the early universe's afterglow to the cosmos we see now. It is comforting that the universe holds such quiet records, allowing us to learn about unseen forces through ancient light. Dark energy appears smooth and evenly distributed, unlike matter, which forms clumps and structures. Matter gathers into galaxies and clusters, creating bright texture across space. Dark energy does not gather this way. It remains spread out uniformly, like a calm ocean filling all of space. This smoothness is restful because it suggests the dominant energy component of the universe is quiet and stable rather than chaotic, present everywhere without creating turbulence. As dark energy becomes dominant, it slows the formation of new large-scale structures. Gravity still binds matter locally, keeping galaxies stable, but accelerated expansion makes it harder for gravity to gather matter across vast distances. Over time, the universe becomes quieter in its large-scale evolution. Existing clusters remain, but new massive connections become less likely. This creates a future that is more settled and open, shaped by gradual widening rather than dramatic change. If dark energy remains constant, the universe will expand and accelerate indefinitely. Distant galaxies will drift farther away, their light stretched to longer wavelengths, becoming dimmer. Over trillions of years, many galaxies will fade beyond detection. This is not a sudden disappearance, but a slow fading like distant light slipping beyond a horizon. The universe becomes more spacious and still, with larger gaps of dark quiet between islands of matter. Perhaps the most restful thought is that dark energy remains mysterious without being threatening. It invites calm curiosity, not urgency. The universe has been expanding for nearly 14 billion years, and dark energy has quietly become part of its unfolding story. Whether it is vacuum energy, a dynamic field, or something deeper still unknown, its influence remains smooth and steady. Space continues stretching outward in silence. Galaxies drift softly apart and the cosmos keeps expanding with gentle persistence, carrying its quiet mystery through endless time. As this quiet journey through dark energy continues to settle gently in your mind, there is nothing you need to hold on to and nothing you need to solve. The universe can remain vast and open without needing your attention. Its slow expansion, its patient distances, and its steady laws will continue whether you observe them or not. You may notice your thoughts becoming lighter now, less defined, like distant galaxies fading softly into a wide dark sky. That is perfectly natural. Just as space stretches without effort, your mind can loosen without effort too. There is no need to reach a conclusion. There is no need to stay focused. Everything can simply soften. Let your breathing remain slow and unforced. Let your shoulders rest. Let your hands stay still. Imagine the universe as a quiet ocean of space, expanding gently in every direction, not as a rush, but as a calm widening. Dark energy does not demand to be understood. It only remains steady and subtle, shaping the future with patience. In that kind of universe, even mystery can feel safe. Even the unknown can feel gentle. Dark energy is a quiet influence, not seen directly, but felt in the long, smooth motion of cosmic time. It reminds us that change does not always need intensity. Sometimes it is slow, sometimes it is silent, sometimes it is simply the universe continuing its calm unfolding. Thank you for spending this time with the Sleepy Scientist. Whenever the world feels loud or your thoughts feel heavy, you're always welcome to return. The universe will still be here, stretching softly, drifting slowly and carrying its quiet wonder in the background. For now, allow the calm to remain. Let the vastness fade into comfort. Let the silence feel steady. And let whatever comes next arrive naturally. Good night.